All right, number 27, a small square pyramid has a height of 100 feet and a surface area of 22,500 square feet. A larger and similar pyramid has a surface area of 28,900 square feet. What is the height of the larger pyramid? Okay, so the first thing that we have to do is always determine what our scale ratio is. So if I'm looking at the small square pyramid, it has a height of 100 feet, right? So it has a height of 100 feet. And the larger pyramid, it doesn't specify what the height is. It's actually trying to tell us that that's what we need to find, right? So in order to find our scale ratio, again, we need a number over a number. I can't say 100 over x, right? Because that x isn't a number, that isn't going to work for our scale ratio. The only thing that we have that is a number over a number would be this 22,500 square feet for the smaller square pyramid and the 28,900 for the larger square pyramid. So if I say small over large in terms of the pyramids or in terms of my ratios, I can say 22,500 over 28,900. So this right here is the ratio of ratio of surface areas, right? And this is my two-dimensional ratio. So that's my two-dimensional ratio. But this is still a ratio, so let me go ahead and simplify. I always like to simplify my ratios just to be on the safe side. So let me go ahead and input 22,500 divided by 28,900. And then I have this decimal here. So let's convert that decimal into a fraction. So math, enter. I should get 225. So let me use a different color here. So 225 over 289. And just because I simplified this is still my two-dimensional ratio. So let me make a note. Still 2D after simplifying. So there you go. So now what we're going to do is take my new two-dimensional ratio, or my simplified two-dimensional ratio, and make that one-dimensional. So currently I have 225 over 289. It's 2D. So let me take the square root of that, right? So 225 over 289. Since we square, the inverse is to square root. So that's why I'm square rooting the 225 over 289. So let's press second, x squared, and then I'm going to go ahead and bring that ratio under the radical. And then I'm going to go ahead and math enter this. So I have 15 over 17. So 15 over 17. So now this becomes my one-dimensional ratio, aka my scale ratio. Okay, so that's my scale ratio, and we are looking for height, right? So we're looking for height, and height is a segment, so therefore it's a one-dimensional object. So I can go ahead and say 100 over x. And yes, the order does matter. I have to put 100 up top and then x down below, because this 15 came from the small square pyramid and the 17 came from the large square pyramid, right? So I need to write 100 over x, not x over 100. So the placement of your numbers do matter. So now I'm going to go ahead and cross multiply. 15 times x is 15x, and then 17 times 100. Of course, that's 17. Oops, that's wrong. That should be 1700. Now I am going to divide both sides by 15 here. So 1700 divided by 15. Oops. And I get this number here. So you see a repeating number of threes. So we're just going to write our answer as x equals 113.33 with the bar above the 2 threes there, okay? And our unit, okay, so I see square feet, but this height being one-dimensional, we just say feet, okay? All right, moving on to number 28. A small cone has a volume of 15.625 pi inches cubed. A larger and similar cone has a volume of 125 pi inches cubed. The smaller cone has a height of 3 inches. What is the height of the larger cone? So I have two cones here. The small cone has a volume of 15.625 pi. So, of course, this is my smaller one, right? So, small. And this is, of course, my large cone. It does say that the larger and similar cone has a volume of 125 pi inches cubed. And we can determine the height of the smaller cone, which says it's 3 inches. So the height of this thing is 3 inches. What is the height of the larger cone? So that is, of course, my unknown. Okay? So always find our scale ratio. We do know that scale ratios are typically one-dimensional ratios, and height deals with one-dimensional object, or sorry, height is a one-dimensional object, right? But I can't say 3 over x because it's not a number over a number. We only have a number over an unknown, right? But I can go ahead and write that down. So 3 over x here. And we'll just put that in the back burner for now. The only thing that we have that is a number over a number is our ratio of volumes, aka our three-dimensional ratio here. So let's do small over large, right? So small over large is 15.625 pi over 125 pi, and this is my three-dimensional ratio because we took both of these numbers from the volumes here. So now let's use my calculator. We know that the pi's do cancel, so I don't need them anymore. So 15.625 divided by 125. Math, enter. That's 1 over 8. Okay, so that's 1 over 8. And just because I simplified this ratio here is still three-dimensional. So that's three-dimensional. So if I were to compare this to this, they would be not proportional because one ratio is three-dimensional and the other ratio is one-dimensional. So I need to make this three-dimensional ratio one-dimensional, right? So if this is cubed, so how do I make this one-dimensional? I have to take the cube root, right? So let's take the cube root of 1 over 8. So here we go. I'm going to take the cube root of 1 over 8. That is second. No. I can just press math. There you go. Don't press second. Press math. And then go ahead and press 4. And then I'm going to go ahead and input that 1 over 8. And that's 0.5. So let's math enter this. And of course, you're going to get 1/2. Okay, so changing this to 1/2, which is now my one-dimensional ratio. Okay, so now I can work with this stuff here. Okay, so I can go ahead and set them equal to each other because the ratios are the same. Let's cross multiply here. So 1 times x, of course, that's x, and 3 times 2 is 6. So x is equal to 6. That's what we're trying to figure out. Okay, that's the height of the larger cone, right? So the height of the larger cone is 6 inches. So h is equal to 6 inches. All right, hopefully I walked you through these two problems here. Alright, so we're going to look at some word problems here. So the surface area of a cylinder is 48 pi square feet. The radius of the cylinder is 3 feet. What is the height of the cylinder? So we have the surface area of a cylinder, which is 48 pi square feet. So the first thing I'm going to do is I'm going to use my formula. It is going to be S equals 2 pi RH plus 2 pi r squared. The surface area is 48 pi equals 2 pi. What's the radius? It is 3 feet. So I'm going to replace r with 3. And I don't know what the height is, so I'm going to leave that alone. So plus 2 pi 3 quantity squared. And then I'm going to go ahead and simplify. So that's going to be 48 pi equals 6 pi h plus, so 3 squared, that's 9, times 2, that's 18 pi. Okay, so now what I'm going to go ahead and do is subtract both sides by 18 pi here. So 18 pi, and then 48 pi minus 18 pi, that's 30 pi, equals 6 pi RH. Oh, sorry, not 6 pi RH. That's going to be 6 pi h. And then I'm going to solve for h. So I'm going to divide both sides by 6 pi. So the pi's will cancel. And then on the left-hand side, 30 divided by 6, of course, that's going to be 5. So 5 equals h. And our unit of measurement is in feet, so it's actually 5 feet for the height, okay? All right, so number 30, the lateral area for a regular triangular prism measures 462 square inches. Calculate the surface area of the prism if the height of the prism measures 11 inches. Round to the nearest tenth. Now be warned, this problem here is going to be very, very challenging. It's actually a lot of work, and it requires you to just pay attention to little things here and there. So let's go ahead and get started with the lateral area. So remember, the lateral area for a regular triangular prism measures 462 square inches. So the base of your prism is a regular triangle, right? So that means the triangle has all sides congruent, all angles congruent. So I'm going to go ahead and draw my triangle, and it is an equilateral triangle. And we are dealing with the lateral area of the prism, which measures 462 square inches, okay? So lateral area. So L, which means lateral area, equals the perimeter of the base times the height of the prism. So we know that the lateral area is 462. We don't know what the perimeter of the base is. Again, the base is an equilateral triangle, so we're going to leave that alone, times the height of the prism, which is 11. So I can rewrite this as 462 equals 11p. Okay, so let me go ahead and hold on to this for now, because it says calculate the surface area of the prism if the height of the prism measures 11 inches, right? So the surface area formula is S equals perimeter of the base times the height. Remember, that is our lateral area here, plus 2 times the area of the base, okay? So, what do we have here? Well, we know that the lateral area of this thing is 462, okay? Plus 2 times the area of the base. Well, we don't know what the area of this equilateral triangle is. The only thing that I know for a fact that the formula is A equals side square root 3 all over 4. That's all I know. So, I have this thing here. 462 equals 11 times the perimeter, right? So what if I do this? Because we know that if you add up all of these sides here, right? So whatever this is, whatever the measure of this side here is, you multiply that by 3, that's going to give you a perimeter, right? So let's see. If I divide both sides by 11 here, the perimeter is going to be 42 inches, right? And now, if I know that we're dealing with an equilateral triangle, and the perimeter of this equilateral triangle is 42, that means I can figure out the measure of one side, because I know that the measure of all the sides should be the same number, right? So I have x plus x plus x, okay, so x plus x plus x is equal to 42, so equals 42, and that's going to give me 3x equals 42. So what is that going to give me? That is going to give me x equals 14. So x equals 14. And let me go ahead and just do this. I should have used the variable s for these sides here. Let's replace s with x, right? So it's a equals x squared root 3 all over 4. But y'all, we figured out what the value of x is. That is actually 14, right? So it's going to be 14 squared root 3 all over 4. And that is going to give you, so 14 squared, what's 14 squared? So 14 squared is 196, and you divide that by 4. That should give you 49 root 3, okay? So that is the area of your base. So S equals 462 plus 2 times 49 root 3. So now I can find the surface area. So 462 plus 2 times 49 root 3. 49 times 2. So 49 times 2 is 98 root 3. And now what I'm going to do is put all this into my calculator. So we're going to round to the nearest tenth here. So it's S equals 631.7 square inches. And that is your answer. Lots of thinking for this one. All right, so number 31, the lateral area of a regular triangular pyramid is 84 square centimeters. One side of the base is 8 centimeters. What is the slant height of the pyramid? Okay, so we're dealing with a regular triangular pyramid. And the lateral area of the pyramid is 84 square centimeters, right? So first things first, let's figure out the lateral area formula for a pyramid, which is L equals 1/2 the perimeter of the base times the slant height. Now remember, we represent the slant height as a lowercase cursive letter L, like this, right? So L represents the slant height, and we're dealing with a triangular pyramid with a regular base, right? So remember, if you have a regular base, then the base has all sides congruent, all angles are congruent. And when I mean the base, I'm talking about the shape of the base, right? So we're dealing with a triangle again. So I'm going to go ahead and draw my triangle. And it's regular, so all the sides are congruent. We're dealing with another equilateral triangle here, okay? So it says one side of the base is 8 centimeters. So this is 8, right? That one side of this equilateral triangle is 8. So therefore, this gets an 8 and this gets an 8, right? So now, let's go ahead and use our formula. The lateral area is 84. equals 1/2. The perimeter is 8 times 3, so that is 24, times the slant height. So then 84 equals 1/2 of 24, that is 12L. So then if I divide both sides by, it's not 84, if I divide both sides by 12 here, you are going to get slant height equals 7, and we're dealing with centimeters here, so 7 centimeters. We do not square this one because the slant height is a one-dimensional object, so therefore we just leave it as centimeters, okay? All right, so number 32, a math class is designing a cone-shaped object with a volume of 32 pi cubic meters and a height of 6 meters. What is the radius of the cone's base? Okay, so based on the information that we have here, we're going to be dealing with a cone where we're given the volume of 32 pi cubic meters and a height of 6 meters. The goal here is to figure out the radius of the cone. So, I think we all know what a cone looks like. It looks like this. Sort of, maybe, I don't know. And, okay, so the base, or the shape of the base of the cone, of course, is a circle. So that's something to know. And since we're dealing with volume here, that means we're going to be using the volume form. So it's going to be volume equals 1/3 the area of the base times the height of the cone, right? And, okay, well, we know that big B represents the area of the base. The shape of the base is a circle. So the area of a circle is pi r squared multiplied by the height. So then let's go ahead and replace. The volume is 32 pi equals 1/3 pi. We don't know what the radius is, so we're going to leave that alone. So I have r squared. And the height is given. It's 6 meters, right? So I can go ahead and replace h with 6. And then look at that. I have 32 pi equals 1/3 pi r squared times 6. And since everything is being multiplied on the right-hand side of the equal sign, I can actually do this. I have 1/3 of 6. A third of 6, of course, is going to be 2, right? So 1/3 times 6, or you can say 6 divided by 3, however you want to approach this. That is going to turn into a 2 here. So I have, what, 32 pi equals 1/3. Oh, I don't want to write 1/3. Why am I doing that? 32 pi equals 2 pi r squared. And then looking at my work here, I have 32 pi equals 2 pi r squared. I think we can all agree that I think we can all agree that the pi's will cancel. So I have 32 equals 2r squared, and then I want to get r squared by itself, so let's divide both sides by 2 here. I have, what, 16 equals r squared, and then this is where you take the square root on both sides, so that is 4 equals r. Okay, so the radius is 4 what? Meters. So 4 meters, okay? So there you go. Hopefully you got a grasp on working backwards, okay?